Good morning to all my geometry students. Today we are going to focus on problems 17 through 20 in your assignments, which are the problems you have written or you have called regarding or expressing that you have had doubts with. So let's begin with problem number 17. Giving the following model, this model right here, which is the one that you have in your assignment, you are given that AC is equal to 12, AQ is equal to 8, BQ is equal to 5, and we need to find the distance between B and D. Notice that line segment BD is a chord and it's also a secant. Okay, so in this case we have the intersection of two chords, which would be BD and AC, and they both are going to intersect inside of the circle, in the interior of a circle. So that means that here we're going to apply our chord rule, okay, in order for us to find BC. Now, applying that rule, we can establish that AC, the distance from chord AC, from points A to C, is equal to chord BD, which represents the distance from point B to D. Okay, so AC is equal to, you can say that AC is AQ times CQ. And we can also say that BD is equal to BQ times DQ. Okay, so having that equality between the two line segments which comprise or conform chords AC and BD, now we can establish proportion, a proportion statement, which says as follows. AC is to BD. Why? Because AC and BD are equal. So we can say that AC is to BD as AQ is to BQ. Now, having established that proportion, the next step would be to simply substitute the values. AC equals 12. BD, well, that's what we're trying to find, the measure we're looking for. We substitute AQ for 8 and BQ for 5. Okay? Now, in order for us to solve for BD, we have to use our what? Our cross multiplication. Okay? And we can say, using our cross multiplication, that BD times 8 is going to be equal to 12 times 5. So BD times 8 is going to be equal to 60. In order for us to find the value for BD, use our division property. We divide on both sides by 8, and BD is going to be equal to 60 divided by 8, which is equal to 7.5. Now we move on to problem 18. Okay, again, we're using the same model. In this case, they're telling us that AB, the distance between A and B, is going to be equal to 8. AP is 17, CD is equal to 7, and we need to find the measure of DP. So for this problem, we're going to use our secant rule in order for us to find DP. Now, according to that rule, it states that AP times BP, notice that, okay, AP would be the measure of this secant, which is AP, okay? AP times BP is going to be equal to DP times CP. Notice again that BP and CP both represent the external segments of both secants respectively. Okay, so that means that AP is equal to AB plus BP, and it also means that DP is equal to DC plus CP. Again, establishing a proportion, we can say that AP is to DP as AB is to DC. Now, once we have established a proportion, our next step would be to what? Our next step would be to substitute the values we are given in order for us to find the measure of DP. Okay? So, when we substitute our values, we have that 17 is to DP as 8 is to 7. Now we do our cross multiplication, and we have that DP times 8 is going to be equal to 17 times 7, which is equal to 119. Again, using our division property, we divide by 8 on both sides, And so the measure of line segment DP is going to be equal to 119 divided by 8, which is 14.88. Okay. Now we move on with problem number 19. Okay, again, we use our same model. Okay, we are given that BD equals 18, AC equals 14, CQ is 5, and we have to find the measure for BQ. Okay, so again, this one is similar to number 17. We're going to use our chord rule in order for us to find BQ. So the chord rule establishes that AC is going to be equal to BD. AC equals BD. Why? Because according to that theorem corresponding to the rule, to the chord rule, it means that we have the two secants, AC and BD, that are being intersected where? At the interior of the circle. Okay? So if AC equals BD, that means that AQ times CQ equals BQ times DQ. Okay? As a next step, we set up our proportion. AC is to BD as CQ is to BQ. Okay? Now, after setting up our proportion, what do we have? We simply substitute or we plug in our values. So 14 is to 18 as 5 is to BQ. Our next step would be what? To do our cross multiplication, and we say that BQ times 14 is going to be equal to 18 times 5, which is equal to 90. Okay? Now, in order for us to find BQ, we need to use our division property and divide by 14 on both sides. So that means that BQ is going to be equal to 90 divided by 14, which is going to be equal to 6.43. And now we finish it off with number 20. Okay, again, the same model. They're telling us that AC is equal to 15, BQ is equal to 9, QD is 4, and we need to find, in this case, AQ and CQ. Okay, again, we use our chord rule in order for us to find AQ and CQ. Okay, we already know that AC equals BD, AC is AQ times CQ, and BD is going to be equal to BQ times DQ. We set up our proportion. AC is to BD as AQ is to BQ. We substitute our values as we did right here, and we can say that 15 is to 13 as AQ is to 9. We do our cross multiplication, and we have AQ times 13 equals 15 times 9, which is 135. In order for us to find AQ, we use our division property, dividing by 13 on both sides. And so AQ is going to be equal to 135 divided by 13, which is equal to 10.38. Okay? But also notice that in addition to finding AQ, we need to find CQ. Okay? So, given this problem, we notice that CQ, the distance from CQ, is going to be equal to AC minus AQ. Why? Because initially, our line segment or chord or secant, AC, is going to be equal to what? The distance from A to C, you can see it right here, the distance from A to C is going to be equal to the distance from A to Q plus the distance from what? From C to Q. Okay? And this is our initial equation right here. But we need to solve for CQ. So that means that we have to subtract AQ where? On both sides of the equation. Okay? So performing that, we know then that CQ is equal to AC minus AQ. So CQ is going to be equal to AC, which is given. The measure of AC is 15. And the measure of AQ is the measure we found in our previous step, which is 10.38. So CQ is equal to 15 minus 10.38, which is equal to 4.62. Okay? So I hope this helps. Any questions or doubts, please continue writing. Please continue calling. And see you soon. Bye-bye.